Today we are solving one of the most beautiful integral in calculus, the integral from 0 to pi by 2 of ln sin x. First use this powerful symmetry properly and replace x with pi by 2 minus x. Now the same integral becomes the integral of ln cosine x. Let's add the both forms together, which gives us I plus I is equal to the integral of ln sin x plus ln cosine x. Using the logarithm rule that sum becomes product, we combine this into ln sin x cosine x. Now we know this trigonometry identity, sin to x equal 2 to sin x cos x, so substitute the value of sin x cos x into the integral. Now we split the logarithm using the quotient rule, which becomes ln sin to x minus ln 2. Let's separate this into two integrals. The second part is easy, which just a constant times dx. For the first integral, we use the substitution 2x equals 2 u. This also changes our limits into 0 to pi. Notice that this integral from 0 to pi of ln sin u is exactly twice the integral from 0 to pi by 2. Now here, again this becomes the original integral I. Subtracting I from both sides gives us this, which is the value of the integral is equal to minus pi by 2 ln 2.